involve you doing if this had been this. Let's see. Somehow an x to the eighth, I had an x cubed in mind. Suppose there was an x to the eighth, which you could probably write like this. That's an x to the fourth now you have to worry about. And you said equal to something. How could you now confirm or convince someone that that strange answer that you eventually will get, or I may give the answer to you, and just ask you to validate it? What would you have to do? Take that strange answer, probably given to you, and raise it to the what? Fourth power problem, and see if it works. I'm saying too much for that bonus. I'm saying way too much for that bonus. Now, a little insight here. Yeah, I'm moving on. I got to move on. What's the fourth root of a negative 1?
1.
No, it's not. Why? Because 1 times 1 times 1 times 1 4 times leads me into 1. I want negative 1. You're in grad school now. I think this is where I found your bonus. Online in a grad school situation. What's the fourth root of a negative 1? I would say 1, but it's not 1. 1 times 1 times 1 times 1 for a check is 1. I want negative 1. Yes?
I.
Tell me again.
It'll be I.
Okay, if it's I, then I times I times I times I will give me negative 1. Here it goes. What do you think it says? We'll check it.
No, never.
4 times. This much is I squared. This much, another I squared. I squared is equivalent to negative 1. I squared, negative 1. 1. It's not I. I've got some clever students in this class. Too bad I can't acknowledge them with their names. I got some clever students in this class. I don't know whether anyone thinks right now at this point. Can anyone maybe tell me what you think the fourth root of negative 1 might be? And they'll leave it. Yes?
I to the third?
Not I to the third. I to the third times I to the third times I to the third times I to the first is going to be I to the 12th. And then if you write I to the 12th, here we go. Got to get me all started here on this. You can rewrite as I squared raised to the 6th. I squared is negative 1. You get 1. I want negative 1. Nice. I'm going to leave it at that. Whoops.
Maybe first.
It's a grad school problem. You might see it in one of these calc classes we offer here. The fourth root of a negative 1. Now suppose on Wednesday, I'll tell you what it is. Suppose I give you the answer. Without you saying I, 1, whatever, professor, I guess. I'll give you the answer. How would you confirm it? If I give the answer to you, how are you going to confirm it? Because some students thought it was, they thought it was I. I multiplied I out 4 times, and it would not give me a negative 1. It gave me 1. So how would you confirm if I do go ahead and give the answer to you? You're going to multiply it out how many times? 4 times. Hoping you'll get negative 1. Nice. That's all I'm going to say. That's your bonus coming up. very critical. So we give you partial credit for the bonus. Let me see who can get this. And I guarantee you, some students, I guarantee you are gonna go online, or AI may help you out. AI does not tell you the truth sometimes. But you may go through and try to find a system here on how to find this. Fourth root of a -1. So leave it at that. So I'll bring it up though, on this. I had a student, before I leave all this and get into something new. Some mathematicians in here. In my 4 o'clock session, she said, Professor, how about a grouping problem? That may involve what we're doing, but it's a grouping problem. Guys, my last example here is find the complex zeros of, I'm gonna close this down. Looks like this. H of x is equal to x cubed plus x squared plus 8x plus 8. This one has only 3 zeros, 3 answers. Now, if I have it written down correctly, I hope I do. I would, since you have 4 terms, you know what it means to do. You gotta set these 4 terms equal to 0. No problem. And solve it. Now she suggested in the 4 o'clock session, she says, Professor, can I, if it gets into quite a few terms, can I group? That's 4 terms. Sometimes grouping will help you. Just take a look at maybe 2 of them at a time. First 2, I can take out x squared for a common factor and have x plus 1 left over. What can I do on my last grouping, 8x plus 8? Take out an 8. No problem. Now, looking at the entire problem now, I now have created a common factor in both those, in the red. What's my common factor now? X plus 1 is in both. Take it out. Leaving x squared plus 8. Yes or no? At least it's not x cubed. Split this up. Solve for x. One of the answers, I'm expecting 3 answers, guys. One of the answers is -1. This one should tell me what the other 2 are. And by the way, guys, that is a quadratic. Think this. I'm going to just treat it like this. I'm going to move the 8 over. Now, it's not a cube. No formula required here. Take a square root, it's plus minus, square root -8. Okay, I want you to tell me the simplified version the best you can. We're into complex numbers for square root -8. You want to have what you think this might look like.
2i.
There you go. Here I'm headed. Plus or minus 2i. Tell me more. Root 2. Samantha, is that you?
Yeah.
You see how she got it? Now this one's finished. It's not one of those long cube x to the 6 type problems. You were expecting only 3 zeros. I have my zeros. She gave me this. And she said also consider this. And those are the answers. And we had a group first. I thought about you. Had a group first. So there could be a little grouping involved there. Then go for it. So guys, that's finished. I've got to get all that out of the way, but that's like a little recap. Took a little time here though on this. Now, part 2. To get this chapter 2 busy. I am presenting this with a handout here shortly. With with this setup. It says sketch the graph of, I'm going to say sketch, make it short. I want to name a function for you, we're gonna sketch it. Which is gonna lead me right in where I wanna go. Now, in this accelerated class, someone tell me, quickly, what's that gonna graph into?
A circle.
Parabola. Now tell me, transformation says, though, don't just stop with the basic parabola, it's gonna be shifted down 9 units. So this chapter 2 says, quickly do it. Just show on the grid real quickly. We'll shift down 9 and draw the parent parabola for this and get out of the way. Now, before I do that, I'm gonna shift it down 9. Vertical shift down here. Just mark it down here, guys. -9. Can anyone tell me? Does this parabola open up or down? It's going to open up. So if it opens up and its so-called vertex turning point is down at -9, it's going to come up and intersect, cross over. It's going to have x-intercepts. Does anyone think they know where the x precise intercepts are when I finally draw the graph? Yes.
At -3, 0, and 3.
Hang on now, -3, and also +3?
No.
She says, Professor, I see that right now. How'd you find it so quickly? She said this equal to 0, factored. We all like doing factoring. And she says, Professor, you can go further, split that up, find the answers, and the answers are 3 and -3. And then connect all this, and you have this graph looking something like this. Now, it opens up. And there's your parabola. You're done. Vertical shift down 9. That takes into consideration a transformation. Now, why did I do this? I'm a little bit more graphing here shortly. Why I did this was, now I'd like to solve this. This quadratic inequality. Now, can someone in this class tell me how have we been approaching something like this in the past? You and I, right here in this class. If you were asked to solve this, someone tell me, how did you approach it?
Sign analysis.
Sign analysis. You factor. Absolutely, she is correct. Lisa, I think it was you. And she says, Professor, go to the number line, use your critical numbers, -3, +3. And guys, I'm not going to show all of sign analysis here. Open, open. And she says the routine now is to start checking to see where to shade in. I'll go ahead and show you. I think in between is where I want to be. Right quickly, if I try 0 here, guys, take it up here, check it. 0 squared, subtract 9 gives me a -9. -9 is less than 0. So all this works. And by sign analysis, that we've done so many times in here, put a comma there. The solution is this for that inequality. Now, since I have the graph in front of me, and I ask you to solve it, it's much easier. I'm going to go through sign analysis again. If you have the graph on the side, what am I going to do? I'm going to say, wait, now he wants to know, when is that graph for x squared minus 9, I see it over there, when is that graph below, less than, the x-axis? And the x-axis is representing 0. The part that's below is this piece. All that of the parabola is below the x-axis. And when is that taking place? From -3 to +3. And you're done. You're going to go through sign analysis. If you have the graph staring at you. Now, can someone real quickly, since this is such an important part for the lesson coming up, suppose it's been this, and I will not use sign analysis again. Can someone tell me right quickly, x squared subtract 9 is greater than or equal to 0. That means it's above. greater than the x-axis, without going through sign analysis, I'll do this for you, and I'm gonna have the student tell me what it looks like. This piece works, and this piece works. And the student tell me how in interval notation are you going to express when is that happening? Go for it.
Negative infinity, comma, 3.
What's negative 3 over there? And can I put a bracket on this one?
Union,
Union, give me more.
3, bracket 3. Infinity.
Beautiful. There's the answer. No sign analysis required. If you have the graph. Okay, so that's a little piece coming up here shortly that I need. Guys, the next one looks like this. Why not? Oh, here we go. Part B. Like this. Another function. Lead me to where I want to go. And this one looks like this. Now, I'm not going to take the different colors and actually show each transformation. We'll just quickly graph the final graph with your help. And that would be a parabola, of course. And can someone tell me, based on your knowledge of a parabola or a quadratic, will this parabola open up or down?
Down.
Now, where are the x-intercepts?
Negative.
If there are any.
There are no.
Oh, there are none. There are none. And this says I should take my parent graph and do what to it? Reflect it across the x-axis. So my parent graph looks like this for transformations. And then if you flip it over, it is upside down. And then do what to it? Vertically shift it down 9. So it's going to look like this. Down here at -9. It's upside down. Oh, whoa, whoa, it's upside down. So let's hope I graph this correctly here. Does it look something like this? Is what the final graph looks like? Even with transformations, that's a graph. Done. Okay, now, suppose I ask you on the side here, now, Aiden, help me out here. Suppose now you were asked to solve this, and Lisa said last time, Professor, you use sign analysis. Suppose I ask you now to solve negative x squared subtract 9 is less than 0. And you have the graph staring at you. Its picture's right there on the board. Can you tell the class what's the answer for this? Negative x squared subtract 9, whose picture is right here. This is the picture of the graph of negative x squared subtract 9. I don't know, when is it less than 0? Oh, I love this problem. I see hands going up. Lisa, let's go back to Lisa.
3i?
Nope. There again.
Is it always?
Is it always below? It says, when is that graph below the x-axis? Is my graph always going to be below? Therefore, the answer to this in no time is that. No sign analysis needed. In fact, I think sign analysis would be very difficult to use in the first place. Now, suppose it were turned around. Now it says, when is that graph, that's this picture, when is that graph above?
Never.
Never. No solution. Easily seen if you graph it. Easily seen, those are the answers. I commend those professors of those students, and I have a few in here, when I ask them to do an inequality, they're doing it by graphing. Even before today, before they saw this. I know some of my students were, when I ask you to solve on a quiz or an exam in here, a quadratic inequality, and most students were using silent analysis, they were graphing, even before today, to get the answer. Look how much more sense it makes to graph it. It's so obvious. This is never, that rate graph is never above 0. No solution. Here, when is it below 0? It's always below. And the graph tells me right there. So I thought I'd point that out. Now the last one to get me really to where I want to go, and we'll really take off with this. Guys, it looks like this. Oh yes. I'd like to grab this. Part C, put it up here. Let's call this G of X. And right now, it looks like this. X squared plus 4x plus 12, and let's hope I had that copied down correct. Now, here's what chapter 2 is all about. I'm so excited about chapter 2. You guys are going to find it to be so easy after I get these items out of the way. You guys told me quickly the graph for this one. You said, Professor, it's nothing but the parent graph shifted vertically down 9. It was. Most students told me real quickly this one. You said, Professor, this is nothing but the reflection through the x-axis. It's upside down, and it's vertically shifted down 9. That's how I got that. Now I need to graph this one. This will be a parabola. Now, can anyone tell me how far down should I shift? I shift down 9 on those. How far down should I shift on this one?
Go up.
Good luck. Or how far up should I go? Good luck. What's wrong? Why can you not tell me as easily as you did on these two? Why didn't you tell me? You think that 12 there on the end tells me to go up 12?
No.
No. It's misleading.
Can we factor the or simplify?
Tell me again.
Factor.
Okay, I am going to factor something here shortly, Lisa, but not yet. There's something wrong with the form. You can't quite tell me in terms of shifting, transformations. I'm trying to bring transformations back in. You can't quite tell me it's going to shift down 9 or something else. Okay, let me do something for you. Hang on, hang on, hang on. Getting too excited about this myself. Now suppose I did this. Use a different color. Right beneath there, here we go, G of X is equal to, oh I love this. Now it looks like this. Oh, Randy, you're good. Now suppose it's been given to you like that. The red. First, is the red equivalent to the blue? Are they equivalent first? They don't look alike. Here's the blue, here's the red. Are they equivalent? If you should actually expand this thing out and simplify it, I think it takes you right back to the blue. Now why, if I ask you to graph, would you prefer this to be in this form? Why would you prefer this form? Tell me something about transformations on the red. Lisa.
There's the horizontal transformation.
Well, first though, this.
Reflection.
Reflection through the x-axis, so the parabola's going to be upside down. Then,
Horizontal shift.
horizontal shift to the right, 2, and a vertical shift up 16. You couldn't tell that in the blue. There's no way. I don't see a 16 up there in the blue, do you? But now since I changed it into that different form, Lisa told me what to do. Reflect it through the x-axis, horizontally shift to the right 2, and vertically shift up 16, Professor, and you'll have the answer. You'll have the graph. Now guys, I could go through all the transformations. We did a quiz on transformations. I think it's on the exam. Let me do this right quickly if I can. Let's see if I can. Yeah, of course I can. Let's do this. Let's do this in blue. Let me get some space here. And let me go directly to the graph without showing all the transformations. And Lisa has helped us out. She's telling me, Professor, on this grid, the parabola should be upside down, it's been reflected through the x-axis, horizontally shifted to the right 2 and up 16. Please tell me. I'm going to move over 2 to the right, up 16, and she's telling me the graph is upside down. So out 2, up 16, is that my turning point? Horizontally shifted out 2, then up 16, is that sort of like my turning point for this parabola? And it's supposed to be upside down. I haven't graphed it yet. Now, Lisa, if I graph it right now, this is a final graph without showing all the transformations. You're saying, Professor, it's going to look something like this, which means it's going to cross the x-axis. I need x-intercepts. Is it going to cross the x-axis? And it might even do what? It might even cross the y-axis as it sweeps down here. Who knows? It may do this and come over and cross the y-axis somewhere in there. Who knows? So I need first to find this. Where are those x-intercepts? To find x-intercepts, always set your function equal to 0. Guys, if you want to take the red one and set it equal to 0, go for it. No problem. Move that 16 over. Learning a little mathematics here. Multiply or divide by -1. I'll get out of your way here so you guys on the side there can see. And you get that. This is all the red. Take a square root. You will end up with x subtract 2 is equal to plus minus, since I'm expecting 2 answers. Plus minus. And square root 16, thank goodness, is 4. And not let me make a mistake there. Beautiful. Move that 2 over, and you have your x-intercept to be those. I did it quickly. Which I think is what, 6? 2 plus 4 is 6, so one of my x-intercepts is 6, and the other is what, 2 subtract 4, what is that, -2? I hope I didn't miss it. It's out here, -2 is an x-intercept. Out here at 6, let me bring it on out to 6 here. Let's see what happens here. Extend this, 3, 4, 5, 6. And another x-intercept is here. Turning point's up there. Is that true? Now, can anyone tell me right quickly, where is, I need it, where is the y-intercept on this graph? Located. How do you find a y-intercept real quickly? You set x equal to 0. Just replace all the x's by 0. Guys, if I go back and replace my x's by 0, it might be easier to go back to the blue one. So if I set all the x's equal to 0, in other words, find g of 0, please tell me, do I end up with 12? I use the blue one. And that means right here at 12, I'll mark it here, is a y-intercept. Woo, not drawn to scale. It's supposed to be a parabola opening down, passing through those points. So it looks something like, let me stretch it out here, something like this. It will come down and do that. A little messy, but good. I think we understand what's going on here. Something like that. Would you guys agree? Not drawn to scale. There's a parabola. give you some vocabulary before we take a break here. This turning point. My turning point, guys, was right here. I know my graph's off a little bit. Was out to up 16. That turning point is known as a vertex. That's your turning point. Over here, my turning point was, my vertex was, on the one over here was 0, -9. The turning point. Just so happens the turning point on that one over there is a minimum. The vertex on this one is a maximum. So I still have a vertex, but it could act as a minimum or a maximum. It all depends on whether that parabola is opening up or opening down. So I got a vertex going on. That last parabola was strange looking, but there's the vertex. X-intercept, Y-intercept, geez. Now, can you imagine on one of my quizzes, or one of the exams, that you would have this? Solve this. You saw that. Which means you would have to do a little factoring, go through and do a little factoring, simplify that as best you can, use sign analysis, and get the answer. But now, since I have the graph staring at me, let's get the answer. You don't have to go through sign analysis. Guys, this says, the way it's written, where am I? I want to know, when is that graph below the x-axis? I think that's what that says. This piece right here is below. That satisfies that. This piece is below. Now, can someone tell me an interval notation without going through all the sign analysis and testing and all that business? What on earth, Samantha, is the answer?
-2, -6.
Negative infinity.
Or negative infinity, to.
Negative
-2, but it's not bracket, and then u to, +6.
It is.
Infinity.
Beautiful. Now, do you understand the benefit of a graph? I had a course in grad school where we did nothing but graphs. The book had all graphs. The textbook this professor was using. All graphs. Every chapter. Something to do with the graph, with the graph, with the graph. I didn't realize the power of a graph until I took that course. That's, geez, who on earth would think I can solve that quickly like Samantha did? Solve that quickly without going through all the details of factoring and checking and critical numbers and test numbers. Sign analysis, she says, no, Professor, you've got the graph right in front of you. It should be that. You guys agree? If I based it on the graph, I saw a hand going up.
Okay,
Lisa.
so for -2 and for 6, there's no square brackets, right?
There not, hang on. It says, when is it below 0? Right there, it's on 0. So I didn't include it.
Oh, they're not included.
Yeah, I did not include that, -2.
I see.
Because it's at 0.
Mm-hmm.
This is asking when is it below, not below or on, it's below. Yes?
I have a question on how we went from the blue g of x to the red g of x.
Try to find where it is. On which one?
Yeah.
On this one?
Are they completely different, or how do?
Oh, whoa, these two?
Yeah.
Beautiful. That's the essence of my chapter 2 tonight. After you see this next little part here coming up, I can do it in 5 minutes. She asks the appropriate question and say, oh, now chapter 2 is going to be easy. It's going to be easy. Now, before I answer your question, could I identify this turning point over here? I know it's going to be a minimum. Could I call it a local minimum? Is it lower than all points locally, close by it? Yes. Is it also the lowest point of the entire graph?
Yes.
So it's also what? An absolute minimum. This one I could identify as 216 as a local. It's higher than all points nearby it, so it's a local maximum. is it also the highest point of all?
Yeah.
Yeah.
Yeah, so it's also an absolute maximum. Now, ooh, you set me up for, hang on. Now, let's say I have 30 students tonight. And I start with student number 1, and I take this strange function here, let's take this one. And I ask them, please, would you replace x by 1 up here, and give me the outcome, the answer. And they would say, Professor, no problem. Now I go to student number 2, 3, 4, and I'll go all the way through. And by the time I get back here, maybe Paul in the back maybe had 30. I say, Paul, would you notice 30 is pretty large, but could you put in 30 for the x's here and crunch it out? Yeah, Professor, no problem. No problem. Lisa may have had number 6 to do it. Plug in 6. I'm gonna have each student to plug in a different number into that function up there and get an answer. And then I'm gonna collect all of them. Now, tell me, convince me that if I get all my answers from all 30 students, they plugged in their appropriate number, he may have had, by the time it got over to him, he may have had number 20. He's gonna plug in 20 for me. He says, Professor, here's my answer. I collect all those answers from all the students, and I see an answer of, someone plugged in their number I gave them, and they gave me an answer of 25. I see a 25 coming in for an answer. Can someone tell me right quickly, that student is wrong? Professor, when they plugged in their number that you gave them, and they got 25 for an answer, Professor, they're wrong. Can someone tell me why? Would I quickly say, no, you did something wrong, you plugged it in wrong, you did the arithmetic wrong, something's wrong, the answer is not or cannot be 25. Can someone tell me, convince me, why? On this function. And then we'll take a break. Oh, I'm looking for the answer. It's going to set me up with all these questions being asked. Let me go in the back there. Samantha.
Because for the most recent graph, because the absolute maximum is 16.
The absolute max on that graphic there is 16.
So we can't go.
How on earth can you get a 25? The graph shows you the highest you can get. I don't care how many numbers you plug in and crunch it out. You can't get anything higher than 16. So if somebody gave me a 25, I would just look and say, you can't get a 25. Professor, I got 16 and a half. No, you didn't. You did something wrong, because the highest you can get on that function up there when you plug in numbers is 16. You can't go any higher. We've already seen the graph. The absolute max, like Samantha said, is 16. So I know right quickly if I was scoring papers and they can turn into 25, Now I keep scoring papers and I see all of a sudden another answer comes out to be a negative 40, which is a strange answer. Is negative 40 a possibility for an answer? Yeah, you just can't go beyond 16. You can't go beyond 16, 16 and a half, 16.000001. No, 16 is the max. That's what the graph shows me. Now remind me before we take the break. You said, this is going to set me up for after the break. You said, Professor, are these two equivalent? Is the blue and the red, before we take a break, are they equivalent?
Yeah, we can complete this.
Are they equivalent?
Yeah.
But no, if I try to compare the square.
Yeah, if you expand this thing out into the math there, the algebra, can't you turn the red into the blue, or vice versa? Blue into the red, could you? Or take the red and just boil it out, or distribute it, or whatever? Could you finally turn this into the blue? Are they equivalent?
I don't know.
I see some looks like, oh, they're not, oh, who said no?
I said no. I tried to do it.
Whoa, 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 we're taking a break. Yeah. Negative. If I expand x minus 2, x subtract 2 times x subtract 2, you know and I know, that's this. That's that. Then of course, I got that. Then distribute the negative sign, I got this. still got 16 on the end. Put my numbers together on the end, these two, I think that's 12. Are they equivalent? Don't scare me. Are they equivalent?
Yeah.
They're equivalent. Now, before we leave, why on earth would I have you prefer that you think of it not like this, like this, like the red one? Why is the preference in chapter 2 for the form, the red form, not the blue, even though they are equivalent? What's so beneficial about the red one? Lisa?
It shows the horizontal.
It shows the transformations. The blue one does not show the transformations. That's why you got to put it in the red one, so you can get those transformations. And then you can graph it. And that's what the lesson's all about when you get back from the break. Guys, take your well-deserved 10-minute break. And we'll finish this up.